we have the course description of thermodynamics, a course dealing with thermodynamic properties of pure substances, ideal and real gases, and the study and application of the laws of thermodynamics in the analysis of processes and cycles. It includes introduction to vapor and gas cycles. So within thermodynamics, whole SEM, we will be able to identify the different properties of substance, of pure substance, ideal gas and real gas, apply thermodynamic concepts. Ito, nagsulod. Okay. Apply thermodynamic concepts and principles in analyzing and solving problems. Wait lang, makita lang ba ang slide? Gi-PDF lang na ko siya kay para ano man good para maka draw and highlight ana tol ana. Kita lang siya no. So, okay. Uh, So apply thermodynamic concepts and principles in analyzing and solving problems. Apply the laws of thermodynamics in analyzing problems. Evaluate the performance of thermodynamic cycles. Bali, sa thermodynamics 1, we have two thermodynamics. We have thermodynamics 1 and thermodynamics 2. So mas broad ang thermodynamics 2 kaysa sa thermodynamics 1. Ang gamay lang ang thermodynamics 1 na scope. So here we have the introduction for thermodynamics. We have the basic principles and concepts and definition. Before ang first law of thermodynamics na pa ang zeroth law, kung makita ninyo sa Moodle na gihatag ni Sir, na added to ang PPT for zeroth law. And then we have the ideal gases, ideal gas laws, processes of ideal gases, properties of pure substance, processes of pure substance, introduction to cycle analysis, which is the second law of thermodynamics, or ang entropy, then introduction to gas and vapor cycles and real gases. So na-upload di ay guys ang dimension ang dimensional units which are ang SI system or ang international system sa mga units, and then ang English system. So ang paggamit sa different kinds of units like Newton, mass, for pound force. So later ma-discuss lang to later. Ano siya. So let's move on. So good morning everyone. Today we are going to tackle about the basic concepts, definition, and principles of thermodynamics. Na siya. So mo ni siyang PPT ni Sir, wala na ko siya na gi-edit. Pero I'll be posting maybe sa YouTube na i-dissect na ko ang per topic diri sa sulod para mas masabtan siya. So let's before we go into thermodynamics, let's have a general overview kung unsa ang thermodynamics sa mechanical engineering. So now we are mechanical engineering students, so we study these four components: ang mechanics, energy, systems, and design. We know that mechanical engineering is a branch of engineering that focuses on mechanical systems. In every engineering course, kay ang end goal jud niya is to analyze, to design products or mechanical devices to alleviate or to solve or to improve the quality life of humans. So that's why gingon diri the overarching goal is design of products to meet societal needs. So ang thermodynamics is under sa energy component of mechanical engineering. Why? Because they say thermodynamics is a science of energy, or we can also say thermodynamics is the study of relationship of heat, work, and energy. And ano pa? Uh, when we recall our elementary days, we have learned about the law of conservation of energy. And ang law of conservation of energy states that energy cannot be created nor destroyed, but can only be transformed from one energy to another energy. Or energy cannot be created nor destroyed, but the total amount of energy converted, the total amount of energy converted is still the same. So example, kung mabasa ninyo ang books, so we have three books guys, ang kay Bergnac, kay Shapiro, and then kay Kengel and Bowles. Bali ang wait lang, sorry. Bali ang ano ni? Recommend ni Sir na basahon is ang kay Kengel and Bowles. Kasi nakita na ko ang Bernac pati ang kay Shapiro dili kay siya ingato ka salbutable tapos dagan kayo ganano. So kung gusto niyo magbasa and mas masabtan ang about sa thermodynamics sa kay Kengel and Bowles mo na book reference. So thermodynamics came from the Greek words therm means heat and then dynamis means power. So because sa sinaunang panahon, we know that ang heat is gigamit siya to convert into power. So we have the first steam engines. Una siya ang mga first na mga mechanical systems na na-create in sa sinaunang panahon. Anyways, thermodynamics governs all energy consuming and transforming devices and system. So next, let's move on sa engineering framework. So we have the engineering framework, we have the theory, the data, and judgment or design. So in the theory, we have the different laws. So we have the thermodynamics, fluid mechanics, we have the mechanics, tanan-tanan dito na sa theory. Then we have the data. So ang engineering framework di guys is same lang siya sa research framework. So we base our solutions for problems sa theory, then we collect the data, and then after we collected the data, we propose a solution a or we propose a solution for the problem and in a way na mechanical system or mechanical technology. So after that, we go to the judgment or the design. So after that na-complete na to ang design, we know that every sa research or even sa engineering, kung mag-start sa problem, mag-end yapon siya sa problem. So it is in the same way, wala man nag-stop ang technology on one end, but gina-improve as time pass by. So mo na siya. Ano lang, move on na ta. So we have the different application areas of thermodynamics. So kung atong masabtan ang universe is gina-govern jud siya sa law of thermodynamics. Anything walay bagay diri sa kalibutan ang dili nato ma-explain na without thermodynamics. Because tanan-tanan is naay associated with thermodynamics. Why? Because just like what I said ganina, thermodynamics is a science of energy. And energy is naga-flow lang siya within the universe, right? So we have the different applications. We have the air conditioning system, we have the airplanes, we have the refrigeration systems, ang heating and cooling, then we have the power plants, the car radiators or the automotives, and then of course we have the human body. So um, we are mechanical engineers. So for us to understand or for us to make and to analyze mechanical systems just like air conditioning system, automotives, power plants, refrigeration system, and airplanes or aircrafts, kinahanglan nato masabtan ang thermodynamics. So kung ano sa ang relationship sa heat work or pati it is because thermodynamics is also the study of effects of heat, work, and energy in a system. Ano siya? So samples na siya. Then we have now the definition of the force units. So sa in any like any other maths, so like calculus, physics, unsa pa ng mga math is we really need to check for the dimensional homogeneity or ang pagkaroon og ano ba? Ah, dapat dimensional homogeneous ang terms sa isa ka equation. So mao na siya dapat. So we have two kinds of system sa units. We have the English system and the SI system or the international system. So sa international system, mao na tong standard na tong ginagamit na Newton, kilogram, meters per second squared. Ang sa English system, mao na siya tong sa pound force, feet per second squared, and the pound mass, the ana siya. So pound mass times feet per second squared. So need nato siya nasadihan, bali ano lang ako siya, scheme lang ako siya diri. You can read about it more sa Kengel and Bowles na book ang about sa dimensional homogeneity. Oh, anyways, ang dimensional homogeneity in simpler words is dapat same ang units sa terms sa isa ka equation. Mao lang to. So, dili pwede na maghalo ang nag-pound mass ka sa isa ka equation tapos ang imong answer is Newton. So, dapat pound force gihapon. Ana good. So, we have the conversion. So, ingon ni sir, kinahanglan daw po nato ang sadihan ang conversion of units because maghatag po daw siya og mga assignments and then practice problems for this. So, we have the beginning ideas and concepts for thermodynamics. So, for that, we have the macroscopic viewpoint and the microscopic viewpoint, or they call it, or ang viewpoint is approach. We have the macroscopic approach and the microscopic approach. So, in order for us to study thermodynamics, we have two kinds of approaches. Macroscopic approach is the study of thermodynamics in relation of we study the general behavior of a system. Sa microscopic approach naman is we study the average behavior of the molecules or the atoms or the particles inside. In simpler terms, ang macroscopic is a whole system itself, kani, example kani, and then ang microscopic is kani. Example, we have these different kinds of atoms na naay, each with unique velocity, each with distances, each with have different masses. So, mao na siya ang microscopic. But in mechanical engineering na thermodynamics, we do the macroscopic approach. So, macroscopic approach is also called classical thermodynamics, while ang microscopic approach is called statistical thermodynamics. So, usually, ginagamit ang microscopic approach sa chemical engineering. So, that's why, di ba, na ay mga moles, mga compute nila ang mga mass per atoms, per molecules inside a system. So mao na siya. Pero sa mechanical engineering is as a whole system. So we get the temperature of the system as a whole, we get the pressure of the system as a whole, temperature, pressure, volume as a whole na siya nga system, not per molecule. So mo lang siya kasimple. Ingato lang siya kasimple. Then we go sa here example. So in a microscopic description, so we have energy of each atom, number of atoms inside the system, ang total energy. So mao na siya sa microscopic description. But we do not use it in thermodynamics na sa mechanical engineering. Excuse me. Here we have the macroscopic description. The energy in both cases is the same, E, or internal energy or energy. In a macroscopic description, atomistic concepts are disregarded. So how we describe the system chosen for study requires a careful selection of properties. So unsa ni siya na kinds of properties? We have two kinds of properties, extensive properties and intensive properties. So we will tackle about it later sa nasa slides. So that are based on observable and measurable quantities. So kung observable and measurable quantities, so example na ata sa planta, dili naman nato kinahanglan na hibal-anon or di naman nato kinahanglan hibal-anon kung unsa ang mga temperature or pressure or distance or energy of per atom inside the system. But unsa atong ginabutang sa planta, we have the temperature gauge, we have the pressure gauge. So as a general na siya. Ana siya. Next is, so In thermodynamics, just like what I said, mao man ni atong ginagamit sa pag-study sa thermodynamics, the macroscopic viewpoint. So it is a state of a thermodynamic system. Ang state is a condition of a system at a specific time with regards to its properties. So katong properties na to, mao to siya ang sa intensive and extensive properties. So it is the enumeration of all of its properties. So in macroscopic thermodynamics, the properties of system are assigned to system as a whole. So whole system, not per molecule. Ano lang siya kadali? Dili na daw ni i-discuss ingon ni sir. Kay wala naman ni siya skip na ta. So how does the state of change system? How does the state of system change? So in thermodynamics, we know that thermodynamics is an there is a interaction of energies, di ba? So here we have the system, kaning color gray diri, system ni siya. We have the system boundary, we have the surroundings. So the system boundary is also called control surface. Control surface ang to. Anyways, balik-balik ko. We have the control surface, the one who separates or which separates the system from the surroundings. So ang system is any other or matter, or also a system is a quantity of matter or a region in space na ato ang ginastadihan. So an example of a system is anything can be a system. So tao pwede maging system. Ang oxygen gas within a container is a system. So anything in the universe can be considered as a system basta mauna siyang ato ang subject sa ato ang problem. So the region outside the system separated by the boundary is the surroundings. Then sa energetic interaction, so we have the energy flow. Flow of energy inside and outside of the system. So basic definitions. So sa system, just like what I said, system is any quantity of matter or region in space that we use for study. So we have two kinds of system, closed system and open system. Pero na po special na system katong isolated system. Pero wala na siya gitopic. Anyways, ang closed system is a system that has energy flow, but there is no mass flow. So kaning mass na flow diri is mass of gas. So mas masabtan nato na siya later. Sa energy flow sa isa sa closed system, an energy can be in the form of heat or work. Then sa open system, mao na tong difference niya. Sa closed system, walay mass flow na ay energy flow. Sa open system, there is mass flow and energy flow. So both na ay energy and mass flow inside an open system. So, unya na yung mga examples. So, we have the system and surroundings. So, we have the universe is equal to systems plus surroundings. So, we are inside the universe. So, we have the system, surroundings. So, iulit na naman to gayin na. We have the closed system inside a surrounding. We have the closed system and the system boundary. So, ang energy flow from the system to the surroundings kay in between lang sa ilaha. Salbut ano naman siya guys no, masabta naman siya. Kay i-explain naman ako later. Agay nina. Then we have the open system. So sa open system, there is a mass flow na ay fixed space or volume. Ang system. Kani siya. So when you say fixed space or volume, is that ang volume sa isa ka open system, actually dili tanan na open system kay na ay fixed space or fixed volume because we have open later, i-discuss na lang ako later. Basta ato siya. So open system have mass flows across their boundaries. So the interactions between system and surroundings, we have Wait lang. Guys, paspas ba ko kaayo or okay lang? Okay ba si paspas kaayo ba ang facing? Sige lang, i-review na lang na to later. So, we have the closed system. So, sa closed system, we have the surroundings and the system. Sa system, if a system does work, it is a form of energy. So, after that, when the system does work, it releases heat as a form of energy. So, one example of a closed system is example ano, um, example we have a cup of water. So, a cup of water here, open di ba siya? So, kanang open na cup of water, is it a closed system or an open system? As of now, it is an open system. Why? Because pwede man nimo mabutangan ang tubig, pwede pa man nimo mabutangan og makuha og tubig ang cup since open ang cup. But kung takloban nato na siya, it means gi-restrict na to ang flow of mass. Meaning, constant na ang mass inside the system sa cup. So, how does work or heat naga-work? So, let's say kaning cup is gikan ni siya sa ref. So, it has a temperature na 22 degrees Celsius. Then, we have the room temperature which is 30 degrees Celsius. Pag ibutang nimo siya sa gawas, ang cup, lamig na tubig, of course, unsa ang isa ka principle sa heat? Heat goes from or travels from higher temperature to lower temperature. So magkaroon siya og thermal equilibrium. So ang 30 degrees Celsius na surroundings kay dire mag-adto sa 22 degrees, so it will balance out na mahimo pud siya 30 degrees. So naa ba siya mass flow? Wala siya mass flow but naa siya energy flow. Mao na siyang sa closed system. So we have the open system. So, ang surroundings and mass flow, we have the power. So, kapag nag-intake og power ang system, so we know that power is the rate at which work is done. Then, after that, when power is being generated, nag-generate pud og heat. So, examples of open systems are turbines, engines, compressible systems, ana siya ang open system. Because na po yung flow, mass flow of gas. So example, we have the piston and cylinder. So it is an example of closed system. Nga example man siya sa closed system. Ay, paspas di ay. Ay, sorry. Paspas di ay, wait lang. Sorry. Maghinahinay na lang ko. We have the closed system. So example is a piston and a cylinder. Mao ni siyang piston, kaning dako na rectangular thing here. Kaning mao ni yung piston. Then we have the cylinder, kani, and we have the gas inside. So, paano siya matawag na closed system? We have the boundary, kani. We have the system boundary or the control surface, kani pod, boundary po ni siya. Wait, kani, boundary po ni siya, boundary, kani boundary po ni siya. Na, boundary ni. And then, unsa ang ato ang system? So, our system is the gas itself around, here. Mao niyang system inside the piston. As we can see, walay agihan ang gas. So, ang mass sa gas inside the piston is constant. Kasi kung mag up and down maning piston diri hantud diri, dili makagawas ang gas nor wala po'y gas na makasulod. But naalang work or heat na ma-generate energy because of this piston. So kung mag-work ning piston, we have the generated work in the form of we have the energy generated in the form of work. Sabtan naman siya, no? Nasabtan na siya, guys, ang example. Okay. So let's move on. So here, we have an open system. Example is a gas turbine engine. So kani siya is kaning yellow. Imagine this is a engine. Engine ni siya, ay turbine. Turbine ni siya. Ang engine is kaning hole. Turbine ni siya. So we have fuel and air. Ang fuel and air, we know that it has mass. So nagsulod siya sa combustor, then the product of fuel and air is also a gas. Nagsulod siya diri sa turbine. And after sa pagsulod sa niya turbine, nag-create og work ang compressor. So it moved. Kani nag-move siya diri. After that na nag-create og movement, nag-generate og energy. So pag-generate niya og energy, nag-work ang shaft diri. Nagkaroon og output ang work. So ana na pod. Then after that, since natapos na siya, the gas here in the compressor goes outside here. So we can understand that there is there are there are. Anyways, we can understand na ay mass flow of gas and energy flow na nahitabo. So we can say that this turbine engine is an open system. So later, pwede mo mag-ask ako og questions if naamoy wala masabtan. So karon, let's go back to let's move on with control volume. So, 'di ba we have open and closed system? So ang open system is also called control volume. Gitawag po siya na control volume ang open system. Ang closed system kay ginatawag siya na control mass. So when we say control mass, control ang iyang mass. Because sa isa ka control system unsa kanyang mass? Mass is constant because there is no flow of mass. So sa control volume, ang gina-control kay ang unsa? Gina-control kay ang both mass and energy. Pero specifically ang mass. So example, we have a nozzle. So ang nozzle ana na siya ibang funnel. Okay, lol. Ana. Mhm. So in a nozzle, agihan siya sa both energy and mass. So we have real and imaginary boundaries. So a real boundary can be fixed or moving. So kaning boundary na ni is the control surface or the system boundary. So unsa ang atong system mao niya ang atong system. For example, mao ni siya ang atong system. Unsang volume of gas na nag-agi diri, then ang energy. So we have the imaginary boundary because since wala man siya hard surface, mao ni siyang imaginary boundary kani. Para sa isa ka sa nozzle. O for example, funnel. Ana, 'di ba funnel ana? We have the imaginary boundary here and then here din. Then we have the real boundary here or the fixed boundary since it is not moving. So this is an example of an piston na naay opening. So a piston, this is a piston na naay opening. We have the moving boundary since kani siya naga-up and down kasi gina-control niya ang volume. So ang volume is hindi siya fixed. It can be increasing and decreasing. So we have fixed boundary here. So ang system itself is not the piston, not this, but the gas inside. kung unsa atong inastihan mismo. So mao ni siya ang unsa ni ang system. Mm. So I will reiterate, ang control volume is an open system, control mass is closed system. So we have the key concept and terms, the closed system, open system, system boundary, surroundings, universe, thermodynamic properties, next na siya na na slide, then thermodynamic state. So we have the equilibrium states and properties. So just like what I said, a state is a condition of a system at a specific time with consolidated by its properties. So unsa iyahang properties, we have temperature, we have pressure, we have volume, we have internal energy, and we have entropy. So properties ni siya sa isa ka system. So properties, it is a characteristic of a system. So properties ni siya. So the system can be either open or closed. The concept of a property still applies. So kung mapa-close man siya, mapa-open, naadya pa ng temperature, pressure, volume, internal energy, and entropy. So we have two kinds of properties. We have extensive properties and intensive properties. So we know when we recall ang ato ang chemistry, extensive properties are properties that are that are dependent of the size of the system. Dependent siya. So kung unsa ang iyang size sa system naga-differ. So example, we have 1 kilogram na 1 kilogram na rock. Kung ato na siyang tungaon 500 kilogram and 500 kilogram. Oo. I joke, 500 grams and 500 grams. Di ba maglahi ang mass? Maglahi po ang iyang volume. Maglahi po iyang energy. So it is additive over the system. Then we have the intensive property, ang kabaliktaran sa extensive. So it is independent of the size of the system. So we have temperature, we have pressure, we have density. We can say that at any point of the system, same lang ang temperature, same ang pressure, same ang density. So like water. So ang water is ang density sa water sa seawater, bisan unsa siya kagamay, same lang gihapon ang iyang density. So we have the specific properties. So specific properties are specific gravity, specific volume, specific sa pa ba? Gravity, volume. Wala na may mga specific. So part siya sa intensive property. Though ang mabasahan ninyo sa sa asa ni sa book, specific density pod sa book, nakaingon man gud sa book sa Kengel and Bowles kay ang specific properties kay extensive properties per unit mass, pero ang lang dito is ang specific volume, pero ang specific density, specific gravity kay intensive gyapon siya. So we have the continuum approach is valid if system is large compared to distance between molecules. So unsa ning continuum? Ang continuum with di ba we have macroscopic approach and microscopic approach. Actually, continuum approach is somehow macroscopic gihapon, but we treat the we treat the molecules in a system as continuous. So to explain what I mean, so example, so di ba continuum approach is valid if system is large compared to distance between molecules. So example, kani ang atong system. Kani ang atong system. Okay. Oo. So we have the molecules nga na dira lang siya so nga. Napod ni. So if ako gusto na ako mag-add to dire, So I can go here, 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 here without going diri sa tunga sa may mga molecules because the distance kay of in a system kay large. Sa sobra niya ka large, pwede ko moadto diri, pwede ko moadto diri. Na dili na ako kinahanglan na i adtuan ning or agihan ning mga molecules diri. So that's why we can disregard the distance or the discontinuity of molecules sa continuum approach. Mao gihapon macroscopic gihapon siya. Pero mao to siya ang explanation sa continuum. So in a continuum we treat the molecules as a continuous matter. So kani siya mao ni siya sa microscopic. Why? Example, moadto ko diri nya, moadto ko diri. Wala mo kay agihan na uban, so adtuan jud ako na dira ko mag-agi. So in that way, we cannot disregard the discontinuity sa mga molecules, dili nato siya ma-disregard. So that's why we use the microscopic approach. Kasi wala naman tayo ibang agihan, dira lang man jud. So ano siya? So we have the state. At a given state, all the properties of the system have fixed values. So state, a condition of a system at a specific time. We have example state 1. State 1 is we have temperature is 25 degrees Celsius and then we have syrup ano na lang 25 degrees Celsius. Ano siyang state 1. So state 1 tapos wait lang value so mag another property kay let's say na siya volume na 25 meters cube. Then, mao na siya. So, mao na siyang state 1. Once na naay isa ka property na mag-change, so let's say nagtaas ang iyahang temperature into 30 degrees Celsius, unsa na ang tawag ani? Though same lang gihapon ang volume, ang tawag na ani is state number, hindi mo ko makasulat eh. State number 2. Since one property of the state changes. So, the overall state of a system also change. Yes. So if no properties are changing, then it is at equilibrium. So across time, kung 25 degrees gihapon siya, then 25 meters per meter cube ang iyahang volume, wala nag-change. Kung wala siya nag-change across the time, nasa equilibrium state siya. Next is, so we have equilibrium. So from subterm naman ng equilibrium, ang equilibrium kay ang pag-balance sa system. Anyways, so lapit na siya mahuman guys. So we have thermodynamics deals with equilibrium states. So we have the thermodynamic equilibrium. So for us to have a thermodynamic equilibrium sa isa ka system, dapat masatisfy ang apat na equilibrium states. So we have four types of states na equilibrium. We have the mechanical equilibrium, the thermal equilibrium, the phase equilibrium, and the chemical equilibrium. So for us to have a thermodynamic equilibrium, kaning apat dapat masatisfy ni siya. Masatisfy ni siya. So kung naay isa na dili masatisfy, so there is no thermodynamic equilibrium. So no driving forces. What does it mean no driving forces? It means walay unbalanced potentials. So walay potential forces na pwede magpa-unbalance sa equilibrium. So we have mechanical equilibrium. So there is no change in pressure with time. So we have example. We have seesaw. We have seesaw. So kapag ang seesaw straight, naa siya mechanical equilibrium. Since ang weight diri o ang weight diri is the same. And then ang pressure under here and sa taas diri kay same lang siya ang pressure. Kaya siya nag-balance. So we have the mechanical equilibrium. Then we have the thermal equilibrium. So sa thermal equilibrium, temperature is same throughout the system. So example is katong example nako ganina, when we have a a cup of water na example na lang init na food na water 35 degrees siguro. Gibutang nato siya sa ref. So kung unsa ang kung unsa ang temperature sa ref, let's say 22 degrees, ang temperature po sa water will become 22 degrees Celsius. So there is thermal equilibrium. Then we have phase equilibrium. So when we say phase, mo na to siya atong ginaingon na liquid phase, solid phase, gas phase, so different phases. So no change in the amounts of different phases. So one example is, let's say we have a 1 liter na water. Oh, anyway, imagine na lang na nabutin na. So we have 1 liter na water. Kung liquid siya, 1 liter gyapon siya. Kung gibutang nato siya sa freezer, nag-ice, 1 liter lang gihapon. Kung iula man nato siya or kaning 1 liter here is pakuluan nato ni siya and it will turn into vapor, 1 liter lang gihapon na siya. Pero in different ano na siya, in different um, units. So ang 1 liter will be converted into kilograms then into atmospheric pressure sa gas. Pero same lang siya og value. Then we have the chemical equilibrium. So in a chemical equilibrium, the chemical composition does not change with time. So how can we say na naga-change ang chemical composition? Naga-change ang chemical composition pag naay chemical reaction. So in a chemical equilibrium meaning dapat walay chemical reaction na matabo. Walay chemical reaction na mahitabo sa chemical equilibrium. So example, a hot water, naula ang hot water sa isa ka metal or let's say iron metal. Wala nagkaroon og chemical reaction between the water and the metal. It's still the same H2O and the iron metal still Fe or iron. So when nasatisfy ning apat ning mechanical, thermal, phase and chemical equilibrium, there we can say that there is a thermodynamic equilibrium sa isa ka system. So one example, we can say na example is sa power plants. Kasi kung ang power plant dili siya na-satisfy ning apat na equilibrium na ay ma-imbalance na isa, of course what will happen sa isa ka power plant? Boom, di ba? Ano lang siya dali. So last, we have the state postulate. So when we say state postulate, rules, one rule. So we have the state of a simple compressible system is completely specified by two independent intensive properties. So what is this simple compressible system? Ano siya? Other term siya for single phase system. So kung saan na po ang single phase system, ang system is example gas lang siya tanan, liquid lang siya tanan, so piston siya na gas lang or piston siya na tubig lang, so sa fluid mechanics. Kasi naapod tayo two-phase system na sa isa ka piston na ay gas na apoy liquid. Anyways, balik tayo sa simple compressible system. Sa simple compressible system, specified lang siya by two independent intensive properties. So what are example of intensive properties? We have temperature, we have pressure, we have the specific properties. So unsa tong specific properties? Specific volume, specific density, specific gravity, So kinahanglan na nato is duha lang. So one example dira is ang temperature and ang specific volume. So this specific volume and temperature, two independent intensive properties na siya. So in a state postulate manggod, we can use only two intensive properties para makuha nato or makompute nato ang value sa pressure, sa enthalpy, sa entropy, sa internal energy using only two, which is specific volume and temperature. Isa ka problem. So mao na siyang sa state postulate. So ingon pa diri, ang simple compressible system in the absence of electrical, magnetic, gravitational motion, and surface tension effects. Meaning, wala, we disregard the electrical components, magnetic, or ang gravity, or even ang mga tension, gina-disregard nato na siya sa isa ka simple compressible system. We only focus on the properties of the gas inside or the phase kung unsa man tong system na nandito. So, a simple compressible system is independent if one property can be held constant while another is varied. So, let's say, katong ganina, we have the temperature, we have the specific volume. So, maingon na nato siya na independent siya, it's because wala siya depend sa isa ka property. So, temperature is temperature, wala siya nag-depend sa specific volume, wala po siya nag-depend sa pressure, the same as sa specific volume. So, mao na to siya guys, ang lesson ni Sir for the first topic na basic definitions, concept, and principles of thermodynamics. So, kung na may questions, pwede mo mag-ask. Pwede na mo magsaba.